Good morning, everybody, and welcome to what is now the 9th edition of the webinars Walk and Talk by the StandICT 2023 project. My name is Ray Walsh from Dublin City University. I'm the Director of the EU Observatory for ICT Standards for the StandICT 2023 projects. I'm delighted to be able to lead off on this particular set of talks for this particular webinar on quantum technologies. And to represent and to pay tribute to the partners in this particular consortium, it's StandICT 2023, Trust IT Services, who are the coordinator, DCU, ourselves, and also Astralo. So without any further ado, just jump straight into it. I'll do a quick overview of the StandICT project, and then I will introduce our speakers. Okay. So the StandICT project is sort of threefold, really. It's got a lot of activities going on and has a lot of outputs as a result of all those activities. It has three pillars on which it is based. It has an open call platform, grants platform, where standardization experts can apply for funding to support their standardization experts. So this is the mechanism by which the European Commission funds the next generation of European leadership, I suppose, in standardization, in particular in relation to ICT standardization. That's the whole rationale behind StandICT. And the grants platform then, through these open calls, and we have several open calls run already, 7 completed and 8 which is currently running until the 9th of November. And the successful applicants then get money to support their involvement in working groups, standards committees, technical committees, etc., across the ICT spectrum. We have a lot of I suppose, experts that we can draw on to support the work of StandICT, and this is done through our technical working groups. The UOS, the European Observatory for ICT Standards, is made up of 12 technical working groups, 13 if you include the academy as well. And these technical working groups do a landscape analysis or landscape report on what's current state of the art in a specific area is. So, for example, we have already released AI landscape, smart city landscape, trust information, and digital twins landscape reports, and they've already been published and are freely available on the Zenoda website. Or if you just check the StandICT website, you'll also see that you have access to all that information. There are more landscape reports in the pipeline. Robotics, IoT, edge, blockchain, ontologies, all are in advanced states of development. Community is large. We've nearly 1,500 registered users on the StandICT platform, over 3,000 LinkedIn followers, nearly 800 Twitter followers, and we have an expert advisory group of leading experts in the StandICT area who support the work in which we do and actively contribute in the technical working groups, sometimes in a leadership role as chair of those technical working groups. And impact reports, everybody that gets an award from StandICT in terms of money becomes a fellow, and we follow their progress in terms of how they are impacting on the standardization landscape, what they are contributing to, and at what level. And we ask them to write reports based on that, and we publish those impact reports so we can see the active, tangible outputs of the standardization engagement based on the StandICT project. An example of just some of the results from the open calls. This is the first 6 open calls put together in terms of the overview of what standards development organizations have been targeted, what topics are the top leading topics, the breakdown of the organization type and the grant type, and the number of applicants that have been funded. Like, so 217 across the first 6 calls. That's 217 experts that are supported, tangibly supported via financial instruments to continue on their active engagement in international standardization and European standardization. So you can see the usual suspects that will be high on the priority list for the European Commission at the moment: cybersecurity, artificial intelligence, blockchain, 5G, quantum, which has been mentioned obviously, and we have in the webinar right now to support that initiative as well. And you can see the breakdown here of the SDOs in the graph as well, like where you can see that the Joint Technical Committee for ISO IEC scored very, very well because obviously it's an ICT-based committee. ISO, ETSI, CEN, CENELEC, IEEE, IEC, CEN, ITU, etc. So lots of the large SDO engagers, shall we say, on the international stage that are represented. As I said, we published the reports, like these impact reports, by following the outputs from each of the applicants. So these particular reports so far, the three that have been, sorry, the fourth open call is in publication at the moment. These show a tangible and real output from each of the fellows that are funded. You can see where they're impacting, which technical committees, which working groups, what they're actively engaged in, and how it's impacting on the field of ICT, their field of ICT standardization. The technical working group's leadership is very, very important, because this is what actively drives these initiatives forward. So these are the chairs of the technical working groups and co-chairs of technical working groups, and they're across these areas. So you can see on the right-hand side, this is the list of the technical working groups that are currently active under the StandICT 2023 projects under the European Observatory: AI, smart cities, trusted information, digital twin, data-driven policy, IT, edge, cybersecurity, blockchain, robotics, ontologies, the academy as well for teaching, and the digital product passport, and TWG and data. And these individuals like Lindsay Frost and Brian McAuliffe, Antonio Kuhn and Ishmael and Joel, Fergal Finn, Jens Geko, these are all actively involved in leading these technical working groups and driving the landscape reports forward. So that results in lots of publications. A quick slide here just to show that the landscape reports that have been generated to date. So what they look like. So we produce a nice glossy open access publication which anybody can download. And you can see here that there's also 4 reports in pre-publishing stage, and 3 that are also in the pipeline in the earlier stage of publication. The standardization report on AI, and this is an old snapshot. It has grown since this, but it had 2,643 views and 2,316 downloads. So you can see that these are actively being downloaded and being used as reference documents. So it shows that the impact of generating these landscape reports, it's not just doing this for the sake of doing it. It has a knock-on effect where people are downloading and using these as reference documents to further enhance the state of play and state of the art in relation to ICT standardization. And you can see here just some of the snapshots of some of the Walk and Talk webinars that have preceded this particular one on quantum technology. The Standards Academy is the last thing I want to just briefly mention. We have a number of leading experts again in the area of teaching about standardization, and they are actively engaged on a monthly basis in scouring the landscape of teaching materials that is available through ISO, the ISO Academy, or through Sensenlec, or through Etsy, through the books that they produce. National bodies produce teaching material all the time, and we sort of grab that new material as and when it appears. We annotate it and make it available through our website, and then we'll be providing training using that material towards the end of the project. And this particular initiative is actively chaired by Brian McAuliffe from Hewlett Packard. And before I finish, because that's the StandICT project, but I just want to mention the HSbooster, which is a sister project, which is also coordinated by Trust IT Service, and DCU is involved, and I'm chair of the expert advisory group for that. And this is a support mechanism which supports Horizon 2020 funded projects and Horizon Europe funded projects. So if you've got a project that's doing something interesting from a technological point of view, and it may have, shall we say, a market-facing output or deliverable, then it's probable that you could be supported by HSbooster to actively engage on the standardization front, so you can get that globalization aspect built into your project. So the HSbooster then supports these projects, provides introductory modules about standardization for people on projects that are not aware of standardization, has a proactive element to it. So there's 3 different phases. Proactive element, which means we actively engage in searching out projects that may benefit from standardization support. And we have an expert-driven premium model where we actually partner up experts, paid experts, to actively engage with the Horizon Europe or Horizon 2020 funded project to help them to plot their own standardization work plan and engage in international standardization. So you can look at the HSbooster website for more information on that. So it's got a number of different objectives, but primarily it's based on building up an EU community of standards around supporting Horizon 2020 projects, serving those projects in terms of actively engaging in their standardization process, and looking at new standards developments and uptake of new technologies, and linking that, making a closer linkage between RTDI and standardization. So the whole objective is to try and from a standardization perspective, is to try and link together the research enterprise standardization initiatives at the association level, at the industry-driven level, link together the education aspect, through the various pieces of academy works, and also the academic initiatives through the higher education institutes and universities. So that's HSbooster in a nutshell. And without any further ado, hopefully I'm running pretty good to time. It looks like I'm pretty bang on schedule. 10 minutes are up. So I'm Ray Walsh, and I'm going to introduce the first of our speakers. The panel of speakers includes Oscar Diaz, head of sector on quantum computing at the European Commission, Richard Pitman, chair of TC86, IEC TC86, and SC86, a StandICT 2023 fellow also. He's been funded through StandICT. Nicholas Spetman, co-chair of the focus group on quantum technologies at StandICT. Nushin Amirfer, project manager, secretariat member for StandICT's focus group on quantum technologies also. And then Jonathan Attia, president at Feynman Foundation and chair by EEE P2995 working group. Thanks very much for all of you for joining us this morning. We have a stellar cast to listen to and to engage with. And without any further ado, to keep on schedule, I'm going to call on Oscar. Oscar, if you could please share your slides and introduce yourself to the audience as well.
Okay, I don't know if you can see my slides. Thank you, Ray.
We can see them.
Yeah. Is I? Okay, and you can hear me properly? Can you hear me?
Yes, absolutely.
Okay, brilliant. Okay, thank you. Thank you, sorry. Okay, so many thanks for inviting me. Many thanks, Ray, and the team for inviting me today. So my name is Oscar Diaz, and I am, as you said, I'm the head of quantum computing. In fact, it's quantum technologies at the European Commission. In DG Connect, we are part of it's unit C2, that is unit for high performance computing and quantum technologies here at the Commission, and we also work very closely with the Euro HPC. I will provide a brief introduction about what we are doing on quantum technologies and basically our standardization priorities. So let me go to the next slide. Okay, so I would like to start providing some context. So just to let you know that this is not something new, or we have been working in this since a long time. So basically, it was 1999 that the EU started the first. It was the first region in the world to launch a public research program in quantum technologies. And later in 2016, I think it was around 4,000 of the researchers here in Europe basically endorsed the Quantum Manifesto, that it was started to define the common strategy of for quantum in Europe. So basically, this enabled the creation of the flagship. That was it's continued a 10-year initiative. So we started in 2018. And it's a 1 billion euros initiative. Basically, the main aim of the flagship has been on not only, has been research mainly, but it's not only on the supporting of research in quantum technologies, but also the transfer those results into industrial exploitation and at the end real life application. So as I said, the flagship is a long-term project. But we have already at this stage have excellent results. In fact, the most successful European computing, and I will talk a little bit about those platforms, started as project of the quantum flagship. So this also has permitted to launch as part of the Digital Euro program different initiatives that are supporting the deployment of infrastructure. One of them is the European Quantum Communication Infrastructure, and the other one is basically the deployment of the quantum computer infrastructure. And of course, this will permit the deployment of quantum infrastructure in Europe. So basically, the European researchers and the citizens can use these technologies. So, well, basically standards, I think I don't need to tell it here, are key to, especially at the stage where we are now, this stage of maturity. So they are essential for basically for new infrastructures, as I was saying, also the deployments that we are going to we are about to implement, and the standards they will basically provide they help with the cost reductions, improvement in efficiency, and at the same time it will ensure the quality, safety, security of the products and services that we are implementing. Also, I wanted to say that the standards will support the compliance with the relevant legislation, and including all the EU regulations that we have. They will also achieve the compatibility and interoperability between the products and components. I want to say also that, however, it's relatively few standards are currently in place in quantum technologies, as you probably know. And we need to lead efforts to move it forward, especially because most of the efforts we have seen that are coming from other world regions lately, and also they are led mainly by scientists more than industry, and we are really focused on the hardware side. So basically, Europe needs to assert itself and ensure that all the voices are heard in the development of these global standards in quantum technologies. This will imply continue to work in all the pillars of the quantum technologies. We are not working only in computing, but we are also working in quantum communications, quantum simulation, quantum sensing, and metrology, and include the standardization as part of the different pillars and activities, especially with the new FPAs. So these are big projects that we are launching now. We are starting on the manufacturing and testing of pilot lines, and also the chipset. Standardization is indeed paramount importance to facilitate the growth and development of efficient supply chains in Europe. The standardization activities will be key also for projects that deploy infrastructures, as I said at the beginning, such as, for example, the deployment of quantum infrastructure for communications, so EuroQCI. EuroQCI will provide this is a project that we are currently implementing, and will provide the integration of quantum cryptography for critical communications in Europe. It combines both terrestrial and satellite components, basically to have a wider coverage. And initially, we provide quantum key distribution services, but long term, what we are looking is to be the backbone infrastructure for the quantum internet. Another infrastructure, as I mentioned at the beginning, it's focusing on the deployment of quantum computers and simulation in Europe. And this we are doing it with the Euro HPC joint undertaking. That is, they are the ones who are basically deploying also the supercomputers in Europe. And this will involve the deployment of HPC integrated quantum computers and simulators integrated with the supercomputers. There are currently 2 quantum simulators that are being installed in HPC centers, one from Germany and one from France. And we just, I think it was last week, that we just announced the deployment of the selection of another 6 hosting entities that will deploy quantum computers based on different European technologies. So the domain of quantum computing is still emerging, and it is not yet clear what kind of technology will be the best for building efficient and functional quantum computers. And this is why basically the quantum computers that will be installed are coming from different promising technologies, all of them developed in the EU, and most of them coming from flagship from projects of the flagship. And of course, the standardization will be key on these technologies. But this is only the beginning of a long journey. So not only on quantum computer, but as I said before, in other areas like quantum communication, and especially quantum sensing. So we need to increase our efforts in order to move from lab to commercialization and to market, to be able to achieve basically the full potential of these technologies. And that will imply deployment of infrastructure, manufacturing, production, and also help on the business creation with things like the quantum fund. And as for any new technology, standardization will help to improve the quantum technologies, basically by providing a common ground for terminology, also to control characteristics and performance. So standardization will also bring the greatest benefits in the area of interoperability and basically cooperation. And until now, standardization in quantum technologies, as I said at the beginning, has been mainly led by academia, but what we basically the EU, what we are aiming is at fostering all the quantum technologies ecosystem, and basically you have a standardization strategy that supports the inclusion of industry. It will be key. Another important initiative, as I mentioned before, that it's the inclusion of the Quantum in the CHIPS Act. The main objective here is to achieve the manufacturing and larger scale uptake of quantum chips, basically, and by developing standardized processes and help of creation of the quantum pilot lines. This is one of the FPAs I discussed before, and also testing and experimentation facilities. And in order to coordinate all this, basically we have a CSA, basically a coordinated for action that is part of the flagship. It's called QCATS. The previous version, the previous action was called QFlag, and they are the ones who are in charge of doing the coordination of the flagship. And this CSA basically has a dedicated work package only focused on the standardization. The idea here is to lead also with the quantum industry. So we have the quantum industry consortium, and we have Oscar Venter that is also into the coordination. And they are involved in, I think one of the speakers today will talk about that, involved in different committees as StandICT, or I think the focus group on quantum technologies. And the idea here is to use the StandICT as a basis to coordinate also other bodies. Here you can see some of the ambitions that are currently part of the work package 3. It is a standardization plan for QCATS. And as you can see, we focus in what is needed for science, such as terminology or measurement methods. Also what is needed for components, such as physical interfaces and functionality, and also what is needed for the system, such as protocol or programming interfaces. A document has been published with more information on these proposed actions, and I encourage you to download it and review it to get more information. You have there the link and the QR. And with this, I finish my presentation. If you would like to know more about what we are doing in the quantum technologies and in the quantum flagship, please, you can follow us on H2020.eu, and I would like to thank you for your time and for the invitation. Thank you very much.
Thank you very much, Oscar. Very, very informative. Just gives a flavor of the volume of quantum technology initiatives that are out there, and the scope of the challenge sort of ahead of us in terms of standardization in relation to this issue. Just a question for Oscar. Oscar, what's a good example of a quantum technology use case, one that is currently being supported by an EC funded project, obviously which has a clear standardization requirement?
So thank you very for the question. So I think I briefly mentioned, I think I could mention 3 of them. One will be EuroQCI. Basically, one of the things that we are doing as part of the EuroQCI is communication, quantum communication infrastructure. It's basically the deployment of national QCI networks that will need to interconnect to basically to allow the seamless connections among the different member states, and also standards. Basically, here standards will be needed because if not, it will be impossible to have a proper interconnection. Another example will be the pilot lines. Basically, I also mentioned it before, we are aiming now at production of quantum technology components at a pre-industrial level, and basically have established standardized ways of producing these components before scaling up with the production of the chips. That also it will be key. So that's 2 examples. There are plenty on some quantum sensing and metrology or quantum computers. The list will be really long. As I said before, I think we are in a key a key moment in the development of these technologies, where standardization, we will not be able to go into commercialization or market without having proper standards.
Okay, thank you very much, Oscar. And thanks for a very, very informative presentation as well. So just once more, thanks to Oscar Diaz, the head of sector on quantum computing at the European Commission. Without any further ado, just to try and keep us on schedule as much as possible, I'd like to introduce our next speaker. Our next speaker is Richard Pitwin, and Richard is the chair of the IEC Technical Committee 86 and SC 86B. And also a StandICT.EU 2023 fellow. So thanks very much, Richard, for joining us this morning. And you see you have shared your screen, and we're already in full screen mode as well. So over to you, Richard.
Thank you very much, Ryan. Thank you very much for the invitation. Let me just make sure I can pass here. I'm sure this question will be addressed by many others in here, but I want to give you the primary reasons that I see for standardization of quantum technologies. Most important is that it's a way of accelerating commercial adoption, safe commercial adoption of this technology, and it does so by establishing commonly agreed frameworks, terminologies, design guidelines, performance benchmarks for the technology. But most importantly, it also ensures interoperability, and that's especially important for quantum technology. It's more important for quantum technologies than any other technology I've been associated with, because it's being addressed by so many different areas, and the definition of quantum differs so hugely. So this is why standardization is particularly important. Now, the concept of I'd like to introduce the concept of standardization readiness level. This is something I attribute to Barbara Goldstein of NIST in the USA. And as you might guess, it is analogous to technology readiness level, which gauges the maturity of a technology. In a similar way, standardization readiness level relates to how useful standardization will be in the course of technology development. So it's closely related to the maturity of the technology, but it's also driven by social needs. I'll just give you a quick example, again attributed to Barbara Goldstein, of where different quantum technologies lie in the SRL timeline. For the earlier standardization readiness levels, you have requirements such as terminology, benchmarks, which are driving the early standards, performance benchmarks, software algorithms, and later on, for more mature technologies such as quantum key distribution, you have those technologies feeding the need for interoperability into standards, and then finally certification. So this is a very good way to summarize kind of the timeline of technology development and it's associated with standardization. And here you can see the different technologies where they lie today. Quantum computers is very vague, because some approaches are very early, some approaches are a little more advanced, so it probably spreads quite far. But a lot of these technologies are developed in very different ways. One of the driving forces for myself is looking at hyperscale data centers, which is my background, and where quantum plays a role in the future of hyperscale data centers. Now, hyperscale data centers will in terms of computation, 99% will always be digital computing. However, you'll increasingly see pockets of quantum compute capability offering what we would call quantum as a service, the ability to, and I think that's already offered by IBM, for example, but the ability to outsource quantum compute capability. So there'll be two important points. There's quantum computation and there's quantum communication. So while quantum communication within a data center, communication within a data center will be safe, it's in a building. If you're communicating sensitive information out of the data center or to the data center, here you need quantum encryption. And so quantum communication and quantum computers are two very important aspects related to hyperscale data centers. And one interesting technology you might see introduced is cryogenics in Iraq, in order to give you high fidelity quantum sources, for example, and quantum receivers. So here's a snapshot of the different organizations. I'm sure a few more groups have been added, but here are the different mainstream standards organizations which are looking at quantum technologies. And I've listed here some working groups as well. Sorry, this working group here it doesn't exist anymore, but it's giving way to something else. But it's clearly a very, very important technology, and there are many standards bodies looking at it. And that drove my my activity on the Standards Fellowship, the need to create some kind of harmonization between these different mainstream standards bodies, which is very, very important. And so my fellowships, there were three main themes with my various fellowships with StandICT. One was cross-SDO, that's Standards Development Organization, harmonization for future quantum networks. Another one was standards development for the quantum physical layer. That means low loss connectors and low loss fibers that are very important if you want to incorporate quantum networks into existing infrastructure. And then finally, standards for quantum photonic integrated circuits. So these are three main areas which I consider very important and I've addressed. And I'm going to describe now how some of the highlights of my fellowships along these themes. I should mention that the groups I'm showing down here are all the standards bodies that I've involved in my various activities. So first of all, one of the important one of my important strategies is to introduce quantum interconnect into mainstream fiber optic standards. I myself chair the subcommittee for optical connectors in IEC, which is the International Electrotechnical Commission, and is one of the largest standards groups for optical communication in the standards world. Also, I chair the Mirror Committee in the BSI, the British Standards Institute, which is the oldest standards institute in the world. First to mention, BSI has its own quantum technology panel, a group which looks at quantum technologies, and is also driving and will be driving soon the need for harmonized quantum groups in mainstream standards bodies. Now, IEC, I'll just introduce Technical Committee 86, as I said, one of the largest technical committees on optical communication. There are three subcommittees. There's fibers and cables. There's fiber optic connectors. I chair this subcommittee. And there's S86C, which is about photonic integrated circuits. All three are very relevant to different aspects of standards of quantum technologies. A joint working group 9 is a special group which looks at optical PCBs. But it's within this group that I put forward the first attempt at standardization for quantum technologies. And it's been approved. There's a TR, which is a technical report, which introduces quantum technologies. And the idea is that this technical report will lay the foundation for new standards for different aspects of quantum interconnect. So these TRs are very important if you're introducing a new technology into a mainstream standards body. This was approved, and this is currently in the process of being, it's starting moving through the different standardization review processes. In addition, during this time, I formed the IEEE UK and Ireland Quantum Group. I'm already chair of the IEEE UK and Ireland Photonics chapter, but I formed this group because the UK is very strong in quantum, and so certainly the IEEE UK and Ireland section should have a quantum group. And this deals with supporting quantum engineering as a very important new engineering discipline. Now, one of the main activities I've done over the last 1.5 years is I have organized and run a number of what we call joint symposia. And the purpose of these joint symposia on different aspects of quantum is to get stakeholders from the mainstream standards bodies, IEC, ITU, ISO, who are involved in this, bring stakeholders from them together and introduce quantum technologies and discuss where standards are required. Now, these are very successful. The first one was held on 23rd of March 2021, virtually. All of these were 3-hour virtual meetings. So we had this in March. We had the Joint Symposium on Quantum Transport, harmonization of terminology, quantum photonic integrated circuits, quantum interconnect and metrology. But the last one, the Joint Symposium on Quantum Technologies, was actually our first in-person conference. It was a 2-day conference held at MPL, hosted by MPL in Teddington on the 13th and 14th. Hugely successful, excellent speakers, including Mark Thompson and Sir Peter Knight and Carol Monaghan. So really excellent speakers, and it was a huge success. And hopefully it will be further, more of these joint symposia will also be in person. That's the idea. And here's a nice group photo we took at MPL. So it's really nice to have people together again. Some of the key findings of all these SDO symposia, there were many, but I wanted to highlight some of the key ones. First of all, in terms of what standards would be most useful, often we hear quantum grade optical interconnect. That's the need for low loss optical connectors, low loss fibers, low loss WDM components. Now, as mentioned, this addresses all infrastructures will have connectors, and connectors provide a disruption which would disrupt say a single photon or entangled photon. And so it's extremely important that you have very, very low loss connectors and very low loss fibers in order to reduce the risk that a quantum particle decoheres. So an example of this, we were working with Senko, who are developing a new range of ultra low loss optical connectors. Here are some examples of advanced fibers, hollow core fiber from Southampton University and Luminicity, which could be a great candidate for low loss fibers with very low nonlinear behavior. And there are in the UK many companies driving the need for quantum networks, especially BT. And so here here you see the need. We have very low loss connectors means that you increase the chance and increase the reach of single photons or entangled photons, which are critical for quantum communication. Another example of these low loss connectors was reported in this paper here. I think about here you see the quantum connector. It has a lower loss than an actual fusion splice. So Senko in this case have done great work in creating this very low loss connector. Quantum computing is another thing that came up. It won't be surprising to many, but quantum computing is an area very much in its infancy. So there's, in terms of recommendations for standards, there's no recommendation that we should standardize different aspects of quantum computing. It should be allowed to breathe and innovate as it can be. The only area where we saw standards is need again for low loss cables to help this activity. And quantum photonic integrated circuits, that's essentially photonic integrated circuits which enable you to access boson sampling and other quantum communication and quantum computation aspects. So this is a group in IEC which deals with photonic integrated circuits. So we've also been strongly involved with them to push this. Now, there won't be a surprise, but I just want to give you a quick introduction to what photonic integrated circuits are. They are essentially ICs, integrated circuits, in which you have the ability to both guide light and slow light down. And if you combine these two abilities, you can do almost anything. You can modulate light, turn it on and off. You can split in different ratios. You can wavelength multiplex it. And there are many platforms, material platforms that serve the basis for these PIC technologies. Silicon is the most common, but you have others all with different advantages and disadvantages. Now, PICs today are used primarily for optical transceivers, but there's a wide range of applications, WM, such as neuromorphic computing, sensors, LiDAR, and consumer health. Here's an example of a programmable optical FPGA. And I mentioned neuromorphic computing. Excellent work here to actually give you some compute capability using light itself. But what interests us is, of course, quantum capabilities. Here's a picture of I think a boson sampling arrangement. Now, another important aspect to address with QPICs is how do you couple fibers to PICs with very low loss? This is of course very important. This is a huge challenge. There are many approaches here which are adopted for normal PICs, and I think the two front runners today, the two most likely candidates, are vertical grating couplers and edge couplers. We also published, it wasn't part of this fellowship, but it should be mentioned that during this period, an international standard was published, which for a type of mezzanine card, which actually hosts different types of PICs or QPICs. And one very nice example of this, of a kind of standard which is unique, is purity of randomness for quantum random number generators. Purity of randomness, how truly random a number is. I think it's a beautiful example of a new type of benchmark we would see emerging from this. So we also developed a number of publications. I'm happy to send these links to anybody who asks. That's all from me. Thank you.
Thanks very much, Richard. Very, very comprehensive and a lot of information available in the slides as well. So just to follow up on just one thing that is going to be of interest to a lot of our audience, I think, is because we're used to hearing about these technology readiness levels, but you mentioned the standardization readiness levels in your presentation. Could you expand a little bit on the link between SRLs and TRLs, and also and a follow-on question to that would be, is Quantum Technologies at TRL level 1 and SRL level 1?
Well, I credit SRLs. I credit the credit for SRLs, as far as I'm aware, goes to Barbara Goldstein from NIST in the US, who introduced the concept. But it's a great and very important concept. The link is between TRLs and SRLs is quite close. They're determined predominantly on the maturity of a technology. However, they're also determined by social need as well. And the question is, SRLs are, where will standards be most useful? So in the early stages, for example, it wouldn't make sense to standardize how you create a quantum computer, because that's an area where people have to be completely free to innovate. And one of the criticisms of standardization is it impedes innovation. And we want to, I want to, remove that stigma. It's areas where it should never impede innovation. But there are areas in which standards can be monumentally useful, even at the beginning. So agreeing a common terminology, especially in the quantum area, is important. So we all know we're talking about the same thing. One of the joint symposia I held a year ago, I had an exercise for everybody. At the beginning, I said, everybody provide a one-sentence definition of what you understand to be quantum. And so we got dozens of definitions of quantum. Of course, all were completely different. And that was the terminology joint symposia. But that really explained why you need this kind of standardization. And in terms of where quantum is, it's how long is a piece of string? Many of the technologies are early. Some of the technologies that are like quantum key distribution are reasonably mature. You even see some first products out there on the market, BT and Toshiba, for example, in the UK. And a lot of these technologies, but it's still the tip of the iceberg. There are so many new ways that people are looking to create quantum random number generators, for example. So many, quantum is everywhere. And it's a question of how do you tap into that pure randomness? And if you have you do it optically, you can do it looking at noise levels, you can do it in so many different ways. So we really have just tapped into this. So it's very exciting.
Absolutely. Thanks very much, Richard. And also, as it's the same with TRLs and SRLs, there's no definite line that separates level 1 from level 2. The whole thing is a spectrum. So you can sometimes be blurred like where the edges would be. But I agree wholeheartedly. Yes, in terms of standardization, we need to do terms and definitions first, and then frameworks, and then we eventually get into more technical specifications and protocols, and then the technology matures, then you can work on interoperability issues, etc., etc. But thanks very much for that, Richard. Thank you. So that's Richard Pittman, Chair of IEC TC86 and SC86B, and also StandICT 2023 Fellow. Next up, and next speaker is Nicholas Spethman, and Nicholas is the co-chair of the StandICT Focus Group on Quantum Technology. So over to you, Nicholas. I see you're sharing your slides already. If you just go into full screen mode and take it away from there, Nicholas. Can't hear you.
I hope now you should be able to hear me.
Yes, we can.
Very good. Thanks for this nice introduction. I'm happy to be here. So my name is Nicholas Spethman. I'm from Physikalisch-Technische Bundesanstalt, which is the German National Metrology Institute, where I'm heading the Quantum Technology Competence Center that has the goal to support the transfer of quantum technologies from the laboratory to application. And of course, one important aspect is standardization in that. And I will try to address a few complementary aspects in my talk, where I will report in my function as the vice chair of the focus group on quantum at StandICT. So the focus group at StandICT was founded in 2020. So here you can see basically the key figures. On the left-hand side, you see the distribution of participating countries. And the main goal of the focus group is not to develop standard as such at this point, but to provide guidance and to identify needs for standardization in quantum technologies. So the question is what to standardize, where are gaps, when does it need to happen, how is it going to happen, and who is going to do it? And this is what I will address in a couple of minutes. Then also another aspect is to coordinate between different standardization bodies. We heard already about this from the speakers before me. And then also the idea was to spin off actual standardization activities. And I'm happy to report that very recently the creation of a joint technical committee at StandICT on quantum technology has been agreed to. So this will happen very soon. Okay, so if you look at the composition of the focus group down here, you can see that about half of the people are from science, a third from industry, and the rest from standardization and other organizations. And this is, of course, reflecting also the early stage of quantum and maybe also the close connection of quantum to science. And the point I want to make here is that the focus group has already and will play a very important role from my point of view as a forum to connect these different communities from academia, industry, and standardization in quantum. And I just brought this very simple picture, well, seemingly simple picture of a supply chain where you have two parties, some kind of a transaction and a product and or service that needs to be exchanged. And there you need a standard. And I'm just showing this here because this is something that scientists maybe do not think about very much. And this is one example where you can see this kind of discussions, and of course, specifically for a component at hand to have in the focus group. I think that is and was a very important role of the focus group. Okay, so I want to say just a few words about, so what is kind of a intermediate result at this point of the focus group of where needs for standardizations are. And this is strongly related to what Richard said about the different standardization bodies out there that are all already active in Qt. And I think the focus group has maybe a kind of a special feature because it includes all the domains. So if you look of quantum technology, so if you look at the domains of quantum communication, computing and simulation, and metrology, sensing and imaging, we have domain experts from all those domains or fields in the focus group. And on the one hand, this is a challenge because you have a certain danger, of course, to have domain experts and only address a certain part of your group at one time. And you have this very broad field of quantum technologies all in one group. So that's challenging. But on the other hand, and this is, I think, a big advantage, it's also a chance. Because many of the components are common across those different domains here. And if you look at this temple picture here, we basically have enabling technologies, base technologies as a foundation that you can combine to subsystems. And from those, you can basically address different of those domains by platforms or systems. And those are relevant in the end for applications and use cases. And the point now is that we have a strong connection here on a horizontal layer between all those enabling technologies. And the fact that in the focus group we have all those domains represented is a chance, because now we can come up with a framework and think about all those domains when we address standardization of enabling technologies, for instance. And of course, this can help to prevent future double development or work and prevent later adaptations. To make this more specific, imagine you have one group on standardization working on metrology, another one working on computing, let's say, and each of them is thinking about some base technology that can be used for both and is coming up for different standards. This would be a problem. And this is what we think is important to consider. And this is also what you can find in the roadmap and also in the preprint that Oscar mentioned already. So I don't have time, obviously, to go into this in any detail. I just wanted to show this rather busy slide to give you a flavor of the level of information we will have in the roadmap. And this is now kind of a zoom in on this temple here. So you have the same horizontal layers, but now it's filled with specific technologies. Let's look at ion traps. So Oscar already showed a picture of an ion trap in his presentation. Those can be combined with lasers and electronics to form a subsystem that can be used for either metrology, for clocks, or for quantum computing. So this would be a very specific example, and you can make others. As you can see, this is by no means complete yet. But this is maybe to give you the flavor of this idea. And our point here is that if we think about standardization of Qt, at least one should consider this structure and make sure that we have in mind that there will be other applications and domains that play a role. Okay, so this was some idea about the how. Now I want to give you just a short insight into the when. So what you see here is also from the roadmap, where you see standardization activity, the time versus the topic. And this is now for enabling technology. So let's say this starts in 2023. And what you can see here is you can think of different domains. And I think we heard about this in Oscar's talk, for instance, closely related at least. You have parameters in testing, and then you have small series production, and later on you will have probably mass production of some Qt components or systems. And the point now is, if you think about what needs to be standardized, one of the first things here is terminology and metrics and test and measurement standards. Some of this is already going on, others is starting. And I also want to make the connection that on a national level, several institutes like PTB and others in other countries are setting up test infrastructure and measurement capabilities exactly for this, for characterizing quantum technology in an independent manner to measure metrics and characteristics. And then, of course, it is important hand in hand to have standardized measurement protocols, characteristics you want to measure, and so on and so forth. And this is something that Richard also showed on his standardization readiness levels. I further on wanted to mention that this is also what Oscar mentioned in his talk. There's also initiatives from the European Commission to support setting up test beds like open testing and experimentation. And I'm happy to say that aspects that go into the focus group on one hand are also followed up in hardware in these initiatives on the other hand. I think this is very fruitful collaboration. Okay, let me show you very briefly another aspect, and this is the timeline for standardization on quantum computing from the roadmap. The same schematic, but now about computing. Again, you see terminology and metrics very importantly and also already going on. And then you also have initial standards for simulators and also for base enabling technologies like ion traps and cryogenic quantum computing technologies. And I just want to mention, these are actually chips, quantum chips. And this is, again, something that Oscar mentioned. And I think this is also very important to see that we have very strong crosslinks here. Okay, and then it goes on to more involved stuff. I don't want to touch upon this at all due to time. Let me wrap up very briefly what I presented here about the focus group from StandICT. So there will be a roadmap very soon about standards, how, when, and by whom. I think it's very important to have this initiative to coordinate on a European level, to be able to also participate in different worldwide activities. And then I showed you some aspects about this coherent framework and mentioned a few first important standardization activities. And with that, my 10 minutes are over, and I'm open for questions. Thank you.
Thanks very much, Nicholas. I think we're going to skip questions until the end because we just want to try and keep it on track. We are running a little bit over, so we want to try and speed up, and we'll take some questions at the end when we have time. I just want to jump straight through into our next speaker is Nushin Amirifar. Nushin is the project manager for the StandICT focus group on quantum technologies, and also obviously the secretariat member as well. So Nushin, please would you share your screen at the moment and in full screen mode, and then you can take over with just testing your audio as well. Hopefully you'll be able to we'll be able to hear you. Over to you, Nushin.
Thank you for the introduction, and thank you for having me here. So good afternoon, everyone. My name is Nushin Amirifar. I'm the project manager at StandICT Management Center in Brussels. I'm also the project manager of StandICT Focus Group on Quantum Technologies. This activity is being monitored through our department, Industry and Electrotechnology. And I'm very happy to explain a little bit about the StandICT activities in general, our standardization activities, ambitious, and the activities we have currently on quantum technologies. So as you already know that the standardization activity is quite vast and it happens at different levels. We have the National Standardization Organization, and We do have at European level SENELEC and ETSI, these three standardization organizations. They are recognized, officially recognized in the European Regulation 1025. And at international level, we have ISO, IEC, and ITU. At SEN and SENELEC, we have a very close relation with ISO and IEC through different agreements. We work closely together, we develop standards together. And I need to also explain that for SENELEC, we are member-based organization. We have a network of 43 national standardization bodies or national electrotechnical committees within 34 countries. And one of the main important features of the European standards developed by SEN and SENELEC is that when the European standard is published, any national standardization standards conflicting with this European standard at the national level, they need to be withdrawn, and the European standard basically will be implemented as the national standards. And we call this basically standstill rules. Well, SEN and SENELEC, we have quite many activities within the SENELEC. We have, I think I mentioned 14, but probably we have more than 14 business sectors. It comes from agriculture, electrotechnology, service, home appliances, mining, railways, anything you could imagine. We have more than 11 business topics, smart cities, smart houses, accessibility, e-mobility, and you can see next to that empty space that you see, it is now the quantum technology, which is one of our important business topics today. We have more than 450 technical committees actively working in standardization. We have 1,800 working groups, and that brings together 200,000 experts. They are the national delegation, they are from European organizations, from societal stakeholders, from NGOs and academia, and I can go on and on and on. So it's a very big network of experts. We have around 24,000 standards, nearly 5,000 of them are harmonized standards. I will explain that in a bit. And we have other deliverables, technical specification, technical reports, and the CWA, it's workshop agreement. It's kind of a fast track to deliver standardization deliverable, basically, and very useful for emerging technologies, for sure. Then it was discussed before by Oscar that why these European standards are important. Basically, the standards are at the heart of the new sustainable digital economy. They also have a key role in implementation of the European legislation. One of the things is that for manufacturers to benefit from the presumption of conformity, they can use the European harmonized standards during their design or production of the products, basically, to make sure that their procedure, basically, or their final product complies with the European regulations. And by that, they also, the standards can help the European single market and also the European strategies and priorities. So since a couple of years ago, the quantum technology topic was discussed heavily at SEN and SENELEC. It's very important for the European organization system, standardization system, to be agile and be ready to respond to the European urgencies and priorities, and also to foresee any future market needs alongside the innovation. And that brings us to the need that we saw after a workshop. I think it was a joint workshop with the Commission a couple of years ago. And with SEN and SENELEC members, they decided to have a platform, a European platform, basically to bring all involved actors to discuss openly about the standardization opportunities related within Europe, related to the quantum technologies. And that is how the SEN-SENELEC Focus Group Quantum was started in May 2020, and it's going to be at least for 3 years active. Currently, we have many delegates, more than 150. There have been many meetings set. At every meeting, we have a discussion among all scientists, industrial stakeholders, academia, that we discuss the topics. We have a very good contributions. My work here is a lot easier because Nicholas already explained very well what is in the roadmap. So one of the main objectives of the focus group on quantum is to scan and monitor and explore the standardization opportunities. And in the timeline, basically what happened before also for the artificial intelligence is first we started with a focus group, we checked the possibilities, we discuss, and we have a roadmap for standardization. And the next step, which is the case here, is to create a StandICT joint technical committee. We have seen enough opportunities through this through the work of the focus group on quantum. And as Nicholas mentioned, I'm happy to announce that since very recently, since last week, I think, we have the StandICT Joint Technical Committee 22 focused on quantum technologies. It was mentioned repetitively before that the area is very different. There are so many different diverse areas of quantum technologies. We try to address as much as possible in this focus group on quantum. And we will keep the same spirit in this joint technical committee. What is, first of all, one of the ideas of this joint technical committee is touching upon so many aspects and areas in quantum technology, also to have this European platform for standardization needs, and also to have the close cooperation with the StandICT international counterparts, and to be the voice of European stakeholders, basically at international level. I forgot to mention maybe that the first release of our roadmap would be end this year or early January. Then I have one more slide. It was also discussed repetitively that how this joint technical committee wants to help if we are going to talk about so many different aspects with that the technology readiness level is not homogeneous, how standardization can basically support. I can split it into 3 different steps. At the earliest stage, which is the knowledge development, technology development, and then the business development. We have different technological readiness level. How every stakeholder can benefit basically from standardization and how standardization can support. At the earliest stage, for example, we can base ourselves on the basic research. There could be the semantic standards. They can facilitate the communication among the researchers or industries, for example. When the technology is more mature, we move to applied research and standards related to the measurements and testing. It can also accelerate the progress towards the first product related development. And then at the higher level, we come to the experimental development. Then we have more standards on the interface and interoperability of the components. And later on, when we are at a very, very higher level of technology readiness level, we have, of course, the business development to use the standard as a catalyst, the market launch and commercialization. And it will become to standards for the product and services and their performance, quality, and safety. So overall, yes, that is actually, I think, my last slide. Overall, I just wanted to mention that how the standardization can facilitate and also save investments while we can use them as a tool to communicate and uniform our approach for further development. I will not take more time. I put the link. We do have a dedicated StandICT quantum technology website, and there are lots of information for joining and how the next meetings are and the documents that are published. That's it from my side.
Thank you very much, Nushin. Thank you very much. Very, very informative. And it's great to see the progress being made. Without any further ado, because we're over time, I just jump straight into Jonathan's talk as well. And please ask the panelists to maybe answer the questions in the Q&A session by typing in your answers. Jonathan Attia. Jonathan is the president of the FANUM Foundation, and he's also a chair of the IEEE 2995 Working Group on Quantum. So without any further ado, Jonathan, can you share your slides, and hopefully we'll be able to hear you okay.
Fine. Do you see my screen?
Perfect, and here it can hear you perfectly. Go ahead, Jonathan.
Thank you. Thank you very much. So, hello everyone. Thank you for Francesco and Silvana for the invitation. I'm very excited to be here with you to introduce IEEE activities about quantum technologies and standard. A full copy of the presentation will be shared with all participants later. So I'm Jonathan, I'm based in Paris, France. I'm president of the Feynman Foundation and the chair of five working groups at IEEE. I'm also participating in WG14 at ISO, and I'm also FGQT member at CEN Senelec. Let's start the presentation. So basically, at IEEE, we have some society, sorry, yeah. We have 39 society, and for each society covers a specific discipline and brings together 2,000 of experts around the world to share the latest innovation and best practices. Standards activity is one of the key activities of the society. And note that the IEEE is a non-profit association, and its standard represents only the community of expert members. And more specifically, among the 39 societies listed, only 2 societies cover almost all the working groups related to quantum technology. We will see later on the distribution of the standard projects between ComSoc and the computer society. This low number of society involved can be explained by several reasons. The first reason is that quantum technology are by definition multidisciplinary. So for governance reasons, it is more advantageous to group them together. The second reason is the low TRL of quantum technology. So we prioritize either the most mature technology, such as communication with QKD, those that have sustained development dynamics, such as quantum computing. So the next slide. Okay. It is likely that we will see new society getting involved in the standardization effort of quantum technology during the next few years. Here, I have listed the society that makes sense with the components and subsystem of quantum computing. It is possible to continue this exercise with the other pillars of quantum technology. And what applies to all technologies also applies to quantum technology, all pillars considered. With particularity concerning quantum technologies, the TRL are variable from one technology. The TRLs are again variable from one element to another. In this Venn diagram, if we distinguish between the hardware, software, and application parts, there are 7 possible approaches to standardize quantum technologies. Add to that variable TRLs, which may make you prefer one approach over another. This case will be illustrated with the following list. Here are the 8 active projects within the IEEE. 2 projects are currently being voted on and should complete the list soon. We have 5 projects attached to the IEEE Computing Society, 2 for ComSoc, and one for the IEEE Nanotechnology Council. So we have the number reference of each standard here. This is the standard in the working group. So it's not published, but it's a pending work. And basically, we can see here each pillar of quantum technology, and for each pillar we have the reference of the working group. As you can see, we have the same working group here relative to architecture and relative to software, I mean low-level software, and some initiative about the communication. And here we can also, this is the reference about the terminology on the the semantic. So okay, if you take this, for example, it is clear that the approach of the P3120 standard project is at the intersection between architecture and low-level software. So P2995 is located on the application layer. It becomes possible to consider each standard from a particular approach and better understand the potential synergies between the standards themselves. Basically, this is the methodology that apply at IEEE. Here we have some review for each working group and project of standard about quantum technology. It's not necessary to explain. You can consult directly the content at the link at the end of this presentation. So basically, we have a standard about the post-quantum cryptography, about the network security, but also for sorry, the before okay, it's not the same topic, sorry. We have also a standard about how can we design a new quantum algorithm, I mean with a speed up acceleration. As you see, we have two speed up, quadratic and exponential speed up. So in this working group, we work especially to identify the quantum primitive and how from the quantum primitive we can design new quantum algorithms, include the quantum primitive. Here we have, okay, this is the directly hardware aspect, but not only the hardware, but it's a very specific standard about the quantum computer. We have the same with the quantum simulator, but it's the vote is pending. It's not published, but you know, the working group, it's a build at the moment. We have also a standard about the quantum simulator, so the same from quantum computing, but the question here is how can we implement a specific program to establish a quantum simulation. So this is the work of this WJ. We have also all aspect of post-quantum cryptography migration. So it's not really the quantum technology, but the migration about the, you know, the standard of 4 protocols about the NIST on this topic. And we have obviously the quantum technologies definition. This is the first stage, and it's I think it's the first working group about the quantum technologies at IEEE SA. And yeah, this is the working group about the quantum, the benchmarking of many quantum, of some quantum computing hardware and software. I think it's one old also working group. And basically, actually, we have established, we have 8 and 9 for now, but very soon 10 active standards project on quantum technology at IEEE SA. We have also we are in liaison with ISO WG14 and soon with SERA and SENELEC. It's the discussion is pending, and it will be very relevant for IEEE SA to establish also a liaison with the working group standard at QUIC. And if you want to join any working group at IEEE, you can tap go on the number of the project .IEEE2.org. This is an example for join the working group about the quantum design, and that's it for me. Thank you very much.
Thank you very much, Jonathan. Unfortunately, we're well over time. We knew that from the start because we have just a jam-packed agenda. I just want to spend the last couple of seconds thanking everybody who contributed. Special thanks to Oscar Diaz, Head of Sector Quantum Computing at the European Commission. Thanks to Richard Pitwin, Chair of IEC TC86, and also a StandICT Fellow. Nicholas Spetsman, co-chair of the focus group on quantum technologies at SENELEC. Nushin Amarifar, who's a project manager at the focus group on quantum technology at SENELEC, and Jonathan Athia, president of Phenom Foundation and chair of IEEE 2995. Thanks to everybody. Thank you for your questions. Thanks to the panelists who contributed to questions and answering the questions in the chats and on the Q&A. And thanks very much to Trust IT for hosting again, and for all the support in the background as well, Francesco and Philomena. Thanks, everybody. Talk to you all soon.
Thank you. Have a good day.
Bye. Thank you.
Bye.
Thank you.
Thank you. Bye.